All right, folks, welcome back. I'm going to encourage you to pause right away here. Try to tackle this guy on your own. So this is a combination of a lot of the integration stuff that we've done up to this point. All right, let's see how you did. So I'm going to have to do some rewriting here. Let's see. So I'm going to rewrite this as the integral 1/2 1 over e of the quantity. Okay, I'm comfortable with 10x to the fourth. This is one of those weird inverse trig integrals, so you're going to have to maybe look it up if you don't have it memorized yet. If you're an AP test taker, you need to get to the spot where you memorize this, but this is going to be on the bottom. Square root of 1 minus x squared minus. Now, you can leave the 5 there or bust it out front if that makes it more clear, but or maybe let's say you rewrite this as x to the negative 1. Let's say that's your math voice says to do that. The next step will indicate something. Maybe it is better to see this. If you write it as 1 over x, maybe you'd see it right away, but this is a reminder that if you rewrite it like this and try to integrate it, you're going to see that there's a problem. All right, so right off the bat, this is no problem. 10, add 1, divide by my new exponent. I'll clean that up in the next step. Minus, that's my constant. I don't care about that. If you look back at your rules from 4.1, this is the integral of 1 over square root of blah, blah, blah is sine inverse. Minus 5 times, all right, now this is what I'm talking about here. Add 1 to the exponent, you'd get 0, and divide by 0, nope, that's a problem. So this is, hopefully that's a reminder that this turns out to be what? Natural log, not x, natural log of absolute x. Okay, now we'd put a plus c here if this wasn't definite, but this is definite. So use my brackets, and I'm going to go from 1/2 to 1 over e. All right, so remember how the fundamental theorem of calculus works. I take this, plug it in first, take this, plug it in second. So now I can clean this up. 10 over 5 is 2 times, I guess we'll just write it as 1 over e for now. I know I'm going to do some cleaning up there, but that's all right. Minus 2 sine inverse of 1 over e. Minus 5 natural log of absolute 1 over e. Later on, I'm going to be able to, I could get rid of those right now if we wanted to. Minus, and I'm going to do the same thing with 1/2, so that's 2 times 1/2 to the 5th minus 2 sine inverse of 1/2. Oh, minus. Yeah, minus sine inverse, and then minus 5 natural log of absolute 1/2. Like I said, you don't have to actually include that if you don't want to. All right, let's see if we can clean some of this up. So I could take this to the 5th, then bump the 2, right? That's 2 over 1, so I can rewrite this as 2 over e to the 5th. Minus, there's nothing we can do there. We'd need a calculator to finish that out. Minus 5 natural log. Okay, I'm going to try to clean this up a little bit. So this is natural log of anything natural log in e you should try to do some work on. So I'm going to rewrite 1 over e as e to the, I'll get a different color so we can see it a little better. This is the same as e to the negative 1. So now natural log and e to the are going to cancel out, and I'm left with negative 1. So negative 5, I wish I wouldn't have drawn that. Negative 5 times negative 1 ends up being positive 5. Minus, all right, now 1/2 to the 5th becomes 1 over 2 to the 5th, or 2 over 32, which then can reduce to 1 over 16. If you can't do this in your head, man, margin, go up, clean it up. We got another mess here, so this is plus. Ooh, I was hoping it would be the same as this, but it's not. So I've got this plus. Oh, wait, no, we can do this. 2 times sine inverse of 1/2. That means find the angle whose sine value is 1/2. So sine inverse, remember, lives from in those two quadrants. So sine of 1/2, that's pi over 6. So this would become 2 times pi over 6. Minus 5. Okay, natural log of 1/2. All right, this is another chance to get fancy here. I'm sure if this was a multiple choice question, they would clean this up similar to this. So I'm going to take this. First of all, I don't need the absolute values because it's positive 1/2. I'm going to rewrite this as 2 to the negative 1. Now remember, that means that this is natural log of 2 to the negative 1, and you can take these exponents and bump them out in front. So this is going to turn into positive 5 natural log of 2. All right, let's try to clean this up now. So I've got nothing I can do there. So 2 over e to the 5th. Wait a minute. I messed this one up. Something's throwing me here. I'm going to make that a positive, but then I got to distribute that negative, don't I? So this is going to be a minus. Sorry about that. That's going to be a subtract. Let's just double check that I did all those right. So this is going to be a subtract. That's going to become a positive. That's going to become a positive, but then it turns back into a negative. Okay, so nothing I can do there, nothing I can do here. We can 5 take away 16. Let's rewrite 5 as 80 over 16, wouldn't it be? Yeah. 80 over 16. 80 over 16 take away 1/16 is 79 sixteenths. Plus 2 times the 2 reduces to become pi over 3. And then nothing we can do there. 5 natural log of 2. Okay. So we can use integrals to find the area under the curve, but the problem is the integral counts the area that's below the curve, below the x-axis as being negative. So there's 2 ways to figure something out. If you want to figure out the integral from 0 to 5 of, let's say, x squared minus 3, well, some of that graph, x squared minus 3, some of that parabola is going to be below the x-axis. So some of that, when you integrate that, some of that area will be negative. But I can change the question and say, find the area bounded by the parabola. Now that's talking about strictly all the area combined together. So you have to take into account when you've got some negative area. So we must clearly identify the region that we're trying to figure out. So we are responsible. Area is always positive, but integrals. So we are responsible. I just used pink. I'll go with a different color. We are responsible for making negative regions positive if we're trying to find the area. Okay, area is always positive. Area is always positive, so we are responsible for making the negative regions positive. So how do you know if the area is going to be negative or positive? Well, you got to make a little sketch. So find the area bounded by the parabola y equals x squared minus 1, y equals 0, x equals 0, and x equals 3. So I'm going to encourage you to try to sketch this on your own. Where are we going from? 0 to 3, so I can kind of make this thing lopsided this way. 1, 2, 3. Oh boy, I'm going to need a lot going this way. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, whatever. All right, I'm going to have you pause, try to make a sketch here. See if you can get a good picture. All right, let's see how you did. So I wish I could have drawn this a little bit nicer. I didn't do a great job. So anyway, so the area bounded by the parabola x squared minus 1. So that's our standard parabola, parent function parabola. That's a shift, a vertical shift down 1. So instead of starting at 0, it's going to start down 1. Now when I go over 1, that's like basically squaring it, and then I don't need to subtract 1 because I'm starting from this new base. So my next point would be here. If you can't do that, if you don't remember that shifting stuff we did back in Algebra 2 and in pre-calc, plug in 1. Plug in 2, plug in 3. When you plug in 1, 1 squared is 1, take away 1 is 0. Plug in 2, 2 squared is 4. Or what I do, I know how parabolas move. They go over 1, 1 squared is 1. They go over 2, 2 squared is 4. 1, 2, 3, 4. Then I would go over 3, 3 squared is 9, so I would go up 9 from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, something like that. So here is my curve, because we're only going from x equals 0 to x equals 3. But we're bounded by the line y equals 0. So y equals 0 is this is the x-axis. So that's this. I'll try to draw it in purple. Bounded by... So you can see our regions. We have these two different regions that we're trying to figure that are bounded by these different graphs, these different curves. So I want to highlight those regions as best I can. I think I'm going to try maybe a light blue here. So this area is underneath the curve, so I'm going to have to take into account that that's a negative right now if I integrate it. And then this area is above the curve, so I can just strictly integrate it. So I'm going to need two integrals. I'm going to need an integral that integrates this area, but we need to make it positive. And then I need to integrate this area, and I can leave it positive. So I'm going to encourage you to pause here and try to see if you can write down the integrals. Just the like write up the integrals that you would need to be able to evaluate this area. Okay, let's see how you did. So, all right, so this is, first of all, a negative region. So the area is, or sorry, it's the region is below the x-axis, so I got to do a negative to turn it back into a positive. And that goes from 0, x equals 0, to x equals 1 of my curve, x squared minus 1, dx, don't forget your dx. And then I'm adding on the next region, but that region is positive, so I don't need a negative in there. That region goes from 1 until 3. My curve is still x squared minus 1. Don't forget your variable of integration. All right, let's see how if you got there. Good. If not, go back and rethink it. Then I'm going to have you pause again and try to integrate this by hand. This is pretty straightforward to integrate. Okay, let's see how you did. So I'm going to throw that negative out there. You know, you can distribute that negative if you want to, or you can wait till later. It looks like I'm going to wait till later. X cubed over 3 minus x. I don't need a plus 3, sorry, a plus c, because I have a definite integral. Plus, nice, it's going to be the same thing, x cubed over 3 minus x, and this one goes from 1 until 3. Now I can start to do a little plugging and a chugging. So we're going to do it with our calculator, so I don't need much space over here. So negative x cubed over 3, dang nabbit, plug in 1. So that's going to just become 1/3 minus 1 minus, now I got to plug in 0. 0, 0, that's going to be 0, so that's easy. Plus, so I've done the first definite integral. Now I'm going to do the second definite integral. Okay, so plug in 3. 3 cubed is 27, divided by 3 is 9, minus 3, minus, because I'm subtracting the second part, 1/3 minus 1. All right, let's see how we do cleaning this up. So I'm going to have a negative 1 minus 1/3 is negative 2/3, but we've got that negative out in front. So I already wrote the negative, so I'm stuck with it again. Plus 9 minus 3 is 6. Then I've got 1 minus, that's negative 2/3, but a negative, so that's plus 2/3. Okay, so this is going to really be 2/3. So let's go ahead and switch this so we have a common denom here. So this would become 18 over 3. So 18, 19, 20, 21, 22. Hey, 22/3. That is one of the first approximations of pi. Believe it or not, if you do 22/3, let's see how close it is to pi. What am I thinking of? That's not even close to what I was talking about. Oh, it's 22/7, dummy. That's the one that I was thinking of. Oh, well. Huh? So they used 22/7 as a value for pi for a long time. Wish it was 22/7. That'd be a lot cooler. Anyway, okay. So now let's try to do this with our calculator. I'm going to do this all just on the calc. I'll just put a check mark on the paper. So remember how you can ask your calculator to do an integral? Alpha F2, function integrate. Oh, shoot, I forgot to put that negative out front. Actually, let's put the negative in here, and I'll show you that it doesn't matter. 0 to 1, and I'm going to go from negative x squared plus 1 dx plus, go back into your integral. We're going to integrate from 1 to 3. Oops, I have 0. 1 to 3, and then I'm going to go back to the other one, x squared minus 1 dx. Shazam! 22/3. Cool, right? Cool. All right, so this gets a little more complicated because we have a much nastier curve, and this looks a little scary, but it actually comes out in the wash. No, it doesn't come out in the wash very well, but it's something. It's not that bad. We get some ease in our answers, but that's okay. All right, so let's have you start off. Find the area of the region bounded by. Well, we have to now first figure out how much of this region is above or below the x-axis. So I'm going to encourage you to pause and try to make a sketch of what you think this curve is going to look like. Gosh, I can't decide on a color. Okay, where are we going? From 1 to E, so I can be lopsided. Oops. Okay, so is this, let's see how you did. You haven't tried yet, pause. Try to make a sketch of this guy. Let's see how you did. Okay, so first of all, I have a, this is what, a reciprocal function? Yeah, this is the reciprocal function stretched. Who cares? Minus 1 shifted down. I do care about that. So the reciprocal functions have asymptotes. They have an asymptote at x equals 0 and y equals 0. Now my shift is only going to be up or down, so this is not going to shift this asymptote at all, but it is going to shift the other asymptote down. Okay, and then my curve is going to look something, if you guys remember, something like this. Now, this other branch I really don't care about, but now if it was a -2, then I would have to flip-flop them around. But okay, so we now need to figure out, so x equals 1 and x equals e. There's somewhere over here, but I need to find this first. So I can't place 1. I don't know if this is closer than 1 or farther away than 1 from the origin. So I have to figure out where that is. So let's do, I mean, this is pretty easy to do. See if you can figure out, using this, figure out the 0 of this function. What's the 0? Well, hopefully you took the equation and set it equal to 0. So y equals 2 over x minus 1 equals 0. Bump over the 1, 2 over x equals 1. Multiply both sides by x, and we find that 2 equals x. So this value right here, this is a value of 2. So now I can go ahead and put my boundaries in there. Color. Man, I'm always stuck on the colors. I should let it go, but I don't. Okay, so I'm going from 1 to E, and remember E is 2.718, somewhere in there. So I don't know. I'm going to call it over here. This is going to be, there's E. There's E, there's 1. So my areas, now I want to highlight these. I'll highlight them in orange. My areas that I want to find this area. Life is good. That's positive, so I don't need to worry about that. This area, if I integrate, that's going to give me a negative value. So I need to make sure that I break up my integral. So I'm going to encourage you to take the next couple seconds. Try to do this by integration. All right, let's see how you did. So my integrals would look something like the integral from 1 to 2 of my function, which I'm going to do a rewrite right now. So that's 2x to the negative 1 minus 1 dx. Okay, now this region is negative because it's below the x-axis, so I need to spin it around, so I'm going to make it a negative. Now remember, what's the other way that we could have done that? I could leave this as a positive as long as I do what with these two? So remember, I could switch the order of these, and I can go from E back to 2. That would actually get me the right answer just as well, and I could leave that as a plus. But I like to always go in the same order, so that's the way I understand it better. But you can do whatever you want. You're the boss of you. Okay, let's see if we can integrate this by hand. I'm going to pause. I encourage you to pause and try to integrate. All right, let's see how you did. So now I'm going to integrate this thing. When I integrate, I add 1 to my exponent. That's going to be 0. I can't divide by 0, so that's that weirdo natural log thing. So 2 natural log, and it's not natural log, it's natural log absolute, minus the integral of 1 is x. That's from 1 until 2, minus, well, it's going to be the same thing, right? So why waste my time here? So 2 natural log of absolute x minus x from 2 until e. Now I can start plugging and a chugging. So this would become 2 natural log of 2. Notice I just dropped the absolute values because 2 is positive. Subtract 2. That's my first group. Subtract. Now I put in 1. 2 natural log of 1 minus 1. Okay, now I'm going to subtract. Maybe it's better to leave brackets still here. So now this is going to become 2 natural log, 2 natural log of e minus e minus 2 natural log of 2 minus 2. Okay. If you can do that in your head and see if stuff cancels or cleans up, I don't know. I always have to do it the long way. All right, so let's see what we can do to clean this up. I can't make that look any nicer. So 2 natural log of 2 minus 2. Okay, now this is something I can clean up. Natural log of 1, I can rewrite that as e to the 0. Any log of 1 is always 0. So this would become 0, so I would minus a negative, so that would become plus 1. Subtract 2 natural log of e. Well, e is really e to the first. So natural log of e to the first, that becomes 1. 2 times 1 is 2. Minus e, but that's distributing a negative, so that becomes plus e. All right, I'm just going to think about this as I'm going to take this negative and make that a negative and make them a positive, so then I can just leave them as is. So I've got a positive 2 natural log of 2, and then minus 2. All right, now we've got some like terms here. 2 natural log, so that's 4 natural log of 2. Oh boy. Minus 2, minus 2, minus 2, that's minus 6, plus 1 is minus 5. And then I've also got an e. Okay, so let's see how we could have done this with our calculator. So let's just double check what this number is so we don't lose it. So 4 natural log of 2 minus 5 plus e, and you always got to put e to the first in there. Okay, so it's about 0.4. Dang it, sorry. You always got to put e to the first in there. So that we get something like 0.49. All right, so I can do this. Look, if you want to just type this in, that's one way. Let me show you something that's pretty slick here. What I'm going to do is I'm going to take this interval, but I'm going to take my function, I'm going to change it slightly. I'm going to change it, and I'm going to make this function absolute value. Let's see if this turns out to be the same thing. So instead of doing y equals 2 over x minus 1, I'm going to do alpha f2 absolute value of alpha, give me my fraction, 2 over x minus 1. Now look at, bad window. So my window should go from 1 until, let's go a little bit farther than e, let's call it 3. And then my min, let's go down, let's go negative 3 to 3, whatever. Let's see how it looks. All right, does that look basically like our... Oh, yeah, sorry. I was going to say, wait, why did it bounce up? That's because I changed it to an absolute value. Let me turn it off and just show you again. 2 over x minus 1. This is what we drew. Remember, we had that little area above and the little area below. I'm going to change my window, negative 1 to 3. Looks a lot nice. Yeah, let's go even better. Negative 1 to 1. There we go. Okay, so remember, that's what we did when we drew our little picture over here. But what I did was I went and I'm going to turn this one off now. Let me just clear it out, actually. I turn this one back on, and I get now that it's going to bounce off of that thing. So now let's see if we can integrate this. Second calc, integrate from 1 until e. Pretty slick, huh? So if you can use your calculator, man, do it to it. So I'm going to write in myself a little note here. So with a calculator, note, if you can use your calculator, you might want to change your integral to the integral from 1 until e, and then absolute value your function. Because that will take all of those negative regions and bounce them up to being a positive.